everyone, and welcome to our presentation on the force analysis of the euthanasia roller coaster. Today, we will be taking you through our analysis of the forces involved in this unique roller coaster design. The euthanasia roller coaster is an art concept created by the designer Julie Jonas Urbanus. It is intended to create a series of G-forces that lead to a euphoric end, which means death with no pain.
So for objective, we can understand the working principle behind the euthanasia roller coaster by using the law of conservation energy and force analysis. Then, we can calculate the velocity of the kart after the initial drop. Besides that, we also can calculate the minimum entering velocity of the kart to complete each loops. And lastly, we can determine the relationship between the velocity of the kart when it is at the top and at the bottom of the loops, which is progressively decreasing loop size. So for analysis overview for these cases, this analysis helps us to understand how the right design achieve its intended purpose by the law of conservation energy. Specifically, we examine 7 loops of varying radii from 100 meters to 3 meters to see how the karts speed at each different radius of loops.
So, to perform our analysis, we applied some principles of physics, specifically about the conservation of energy and circular motion of dynamics. So, first of all, we began by calculating the initial velocity of the kart after the initial drop from a height of 500 meters. So, in this case, we're using the law of conservation of energy, and we come out with the final equation of V equals to square root of 2gh, and will leads to the speed of approximately 99.04 meter per second, and the equation can be seen on the left side of the presentation. And after that we're looking for the minimum velocity for the kart to complete each of the loop. In this case, we're using the Newton's equation of motion along with centripetal force equation, and we've managed to come out with the final equation of V equals to square root of gr, which can be seen on the right side of the presentation. Lastly, we're also looking for the velocity at the top and the bottom part of the loops by applying the law of conservation of energy, and we've come out with 2 final equations, which is the equation of finding the velocity at the top, which equals to square root of velocity at the bottom squared minus 4gr, and the second equation is to find the exit velocity, which will become the velocity at the bottom for the next loop, which equals to v at the top squared plus 4gr.
Let me share the results of our analysis. The first table here shows the minimum entering velocity the kart should have to complete the loop at normal conditions. The second table shows the velocity at the top and also the entering velocity at the bottom. So as you can see here, the entering velocity at the bottom is 99.04 meter per second, approximately 10 G-forces. For instance, at the top of the first loop with a 100 meter radius, the minimum velocity which is at the top is approximately 76.71 meter per second, and after exiting, it was around 99.04 meter per second. It goes back to 99.04 meter per second every time as we assume there is no energy losses. As the loops decrease in size, the velocities at the top change accordingly. By the time we reach the smallest loop with a 3 meter radius, the top velocity was 98.44 meter per second. It is the closest to the entering velocity as the distance between the top and bottom is no longer significant to convert much energy from potential to kinetic energy or vice versa. We plotted the graph and this is roughly the result. We can see the obvious increase in the velocity of the car at the top of each loop as the loop radius decreases one by one.
In conclusion, a euthanasia roller coaster can be done by varying the radius of each loop as there is friction and air resistance in the real world. By calculating the velocities in the analysis, we had a clear understanding of the ride's dynamics despite ignoring the friction. Overall, this analysis proves the importance of precise engineering in achieving such extreme conditions. However, further studies can be done to make something similar like the euthanasia roller coaster to exist in the real world, as our study neglected a few important elements such as friction and air resistance. Thank you all for your attention and engagement today. As we conclude, just remember, change begins with understanding and action transforms vision into reality.